Hi everyone, thanks for joining the call. In the last video, we have discussed the high level Oracle database architecture configuration. Today, we are going to discuss about the DB architecture in detail. So, the instance is split into memory plus background process, and the database where the physical files present. Some of the data files are some of the files are data files, control files, redo log files, archive log files, parameter files. In today's class, we are going to discuss about all these things. This is the high level division, but if you are going to split this, the memory we are referring here now, it is split into two components. One is SGA and PGA. Okay. About PGA, we'll discuss later. So let's assume the memory is only PGA as of now, SGA as of now. Okay. This PGA is for each user connection it will be separated. This is private for each connection. Okay, for example, if a user one connects to the database, a separate PGA will be created, and a user 2 connects to the database, a separate PGA will be allocated. PGA1, PGA2, that is for each user connection a individual PGA will be allocated. This PGA can't be shared by other users. But the CSGA is common for all the user connection. You can consider SGA as a shared memory and PGA as a private memory. Okay. There are many background processes, but I will provide you uh, the important background processes. One is SMON, PMON, DB writer, log writer, arc writer, checkpoint, checkpoint writer. These are all the important background processes. We are going to discuss about each of its function in this class now. Likewise, the PGA is divided into shared pool, Java pool, read buffer, data buffer. These are there are many things, but these are the primary components of the SGA. I repeat. The instance is split into memory plus background processes, and the memory is further split into SGA plus PGA. The SGA is common for all the user connection. That means if there are 10 user connection, all the 10 user connection is going to share the same SGA, but the PGA will be individual for each of the user connection. And the background processes are important. Background processor: SMON, PMON, DB writer, log writer, archive writer, checkpoint writer, etc. This is how the instance is splitted, and the database contains all the physical files: the data files, control files, redo log files, archive log files, and parameter files, even password files. Now let us see uh, the function of each of the processes. The shared pool is further divided into library cache and data dictionary cache. Now let's say a user is uh, is executing this query. What is the query? Select name age from HR employee. This is the this is the query executed by the user. Okay. Now let's see how this is processed inside the Oracle database. First, let us assume the listener established the connection and the server process is created. Okay. Now first, it the server process will come to the shared pool in and inside the library cache. It will check this query is executed before or not. This concept is called parsing. Okay. Let us assume this is the first time the user is executing the query and it is not present. It is not parsed yet. Okay. So it will check three things. Okay. The server process went inside the library cache and it found that the query is executed the first time, so it has to do the parsing. Okay, so the first step is syntax check. Okay, so the server process will check the syntax of the query is correct or not. Select name age from HR table. If everything is correct, the syntax step is okay. Then it will go for the semantic check. What is semantic check? It will go inside the data dictionary cache and check whether the user have all the enough permission to view the table. See here, it has it has to get all the privileges to select the employee table. If that is okay, then it will pass the semantic check, then the query transformation. So then comes the optimizer. It will transform the query, it will use index if required, and then it will prepare the execution plan. This is how this work. So now you understand the use of library cache and data dictionary cache, right? Now let's see if the query is executing again. Let's say we executed this query before, no? Now if we are using this query again, it will come to the library cache and it will check whether the SQL ID is present or not. If the SQL ID is present, then that means the query is passed already. So it won't do the second step. No, it won't do the parsing again and again. It will directly uh, use the previously passed execution plan. This okay. Now you understand, no? The library cache contains the SQL ID, the parsed information, okay, and it will use the data dictionary cache to check check the syntax and semantic check of the table of the query. Now, now it has to get the data, right? The server process will check the information in the data buffer. Now you have to understand all the data will be inside the database data file, no? So the server process will fetch the required data and put inside the data buffer cache, okay. From there it will for example, the name is Surya and age is 40. It will import the row, complete row from data file and put it in the memory inside the data buffer. From there the user gets the data, okay. This is how select query work. Now let's say, now the user is uh, using some update statement. Now the user is executing this insert statement. Okay, first first the server process will come to the library cache and it check whether the query is executed before or not. Okay, let's assume it is not executed before, so it has to do the parsing. Okay, it will check the syntax check. If the syntax is correct, then it will go for the semantic check. It will check go to the data dictionary cache and check whether the user has enough permission to view the uh, and insert the employee table. If it is correct, then it will go for the third step and the optimizer will generate an execution plan. Okay, after that it will come to the data buffer and read the data of the employee table. Here the user is uh, going to insert a new record to the table, right? So so it will uh, write those changes into the redo buffer. So what is redo buffer? It records all the changes, even for update also. For example, you are going to update the name from X to Y also. All these changes will be recorded in the redo buffer. Okay, and from the redo okay, but you understand the instance is a volatile in nature. These are memory. Okay, once the database server is down, all the information will be erased, right? So it has to be returned back to the physical files. How it will write? With the help of the background processes. Okay, so data file, control file, read log files, For your easy understanding, I am using update statement. It will be easy for you to understand. Okay, so here it will fetch the record for the name A in the data buffer, and it will update the existing age with the new age 29. Okay, so it has to be reflected back to the database, right? So with the help of background process. So before that you need to understand what is redo. All the changes in Oracle database will be stored in the redo log, where the redo log is there inside the database, right? It's a permanent file, but in the memory also we'll have a redo log buffer. So when you make any changes, first the changes will be written into the data buffer, as well as all the details of the change will be written into the redo log buffer here in the memory. Okay, we have log writer background process. This log writer will return the changes in the redo log buffer to the redo log file on three conditions. When the redo log buffer is one third full, if the redo log buffer is one third full, it will write the content. All the changes in the database will be written in the redo log buffer, right? It will be returned back to the redo log file if the redo log buffer is one third full, or every 30 seconds, or when the user commits. Okay, if any one of the condition is met, the log writer background process will return the content in the redo log buffer cache to the redo log files. Okay, so then what is db writer? We have done a change in the database buffer, right? We have updated the age of a from some value to 29. Okay, so the changes has to be returned back to the data file, right? With the help of db writer. How the db writer will write the data back to the data file? When three condition is met. The conditions are: Yes, when the data buffer cache is one third full, all the all the data in the 30 blocks in the data buffer will be written back to the data files by the DB writer, or every 30 seconds it will be written uh, to the data files. Or when checkpoint occur, if any of the three condition is met, the changes the dirty buffer data is written to the data files. This is the function of log writer and DB writer. So what is archive log files? So we we have all the changes logs in the redo log files, right? So they have some limitations, they have some storage capacity, right? Once it is full, it will be erased automatically, right? So before that we need to archive the redo log files, right? So once the redo log is full, the archive process will copy the content of the redo log before it is rewritten to the archive log files. It is like taking the backup of archive log files. The archive files means like it's like the backup of redo log files. Okay, and we have SMON and PMON. Now let's say during the process itself, you update the age, uh, and the the data is written to the redo log file, but it didn't uh, get written into the data file. Before that itself, the DB got shut down. Okay, now you start the database. The data here will be something before then 29, right? Because it is not yet get reflected to the data files, and the data in the memory will get erased. Here come the SMON process. The SMON process will do the recovery. It will it will read the redo log file and write all the changed data which is not written to the data file, and it will first do the recovery, and then only it will make the database open. You understand, no? This is the work of SMON process. The SMON process will do the recovery. Then what is PMON? The PMON, it has multiple roles. One is it will handle the logs. Uh, it will it will register the instance to the listener, etc. We will uh, learn about this all these things in detail in the next course. The next class we are going to learn about listener. Thank you.